In this video, we're going to look at how to name ionic compounds. So before, we learned what an ionic compound was, a metal and a nonmetal. Then we learned how to write formulas for when the metal and the nonmetal combined. Now we're going to learn how to name those formulas. Okay, there are 4 steps for when you name an ionic compound. The first step is to name the cation. You use the element's full name. Okay, if the cation is a transition metal, you must use a Roman numeral in parentheses to indicate the charge. Then, okay, the third thing, if you have a monatomic ion, and this would be the anion portion, you use the root name plus IDE on the end. If you have a polyatomic anion, then you write the name of the ion. So it's pretty easy, okay? You have to recognize really only when something's a polyatomic ion and when something is a transition metal. So let's try a few examples here. All right, we find Na. Na is sodium. When we look at bromine, bromine's just the element. It's not a polyatomic ion, so I go bromide. Take off the ene and add the ide. Okay, CaCl2. I look at Ca, which is calcium. We find Cl. Cl is chlorine, so I go chloride. Now I get to Cu, which is copper. And I have to recognize that copper is a transition metal, so there needs to be a number there in parentheses. Okay, and then we go, all right, what's I? It's iodine, so we go iodide. Now to know the charge that goes in here, you've got to actually kind of go backwards and look at the charges. All right, if I have Cui2, I will gain 1 electron. Okay, and there are 2 of them. So that's a total of 2 minus, which means copper had to be a total of 2 plus. So I put a Roman numeral 2 in there. NiO. Ni is nickel, okay, and O is oxygen, so we do oxide. Nickel is a transition element, so I need my charge in parentheses. So I have to go backwards. All right, I say O. Okay, O is in group 16 and wants to gain 2, so that's a 2 minus, which means Ni is going to be a 2 plus. Just got to remember the Roman numerals. Okay, 1, 2, 3, 4, 5, 6. Be VI. Usually we don't go over 6. Okay, so remember that 5 is a V. All right, now we're going to look at the polyatomic ion part. So if I want to name an oxyanion, oxyanions are just polyatomic ions that are composed of a nonmetal and oxygen. Think oxyanion, oxygen. There's often more than one combination. So let's take nitrogen and sulfur for example here. Since there's often more than one combination of the nonmetal and oxygen, we have to be a little bit more careful when we name these. Okay, so the one that is the greatest number of oxygens those are given the root name ATE. The lesser number of oxygens is the root name and ITE. Those are for nitrogen and sulfur. So you have things like NO3, which is nitrate. But you have something like NO2, which is nitrite. These are all on the back of your periodic table, but this is how we get those funny names. Okay. Now we go to look at chlorine. Chlorine has more than 2 possibilities. Okay, chlorine actually has 4 possible combinations of Cl and O. So we start with ClO4, and we've got ClO3 minus ClO2 and ClO. Okay, greatest number of oxygens. Instead of just being 8, okay, you get per the root name an 8. In this case, it's chlorine, so it's perchlorate. The next one then is just the 8. Okay, so we get the root name and 8. In this case, it's chlorine, so it's chlorate. Now we go to the ite. Root name and ITE, chlorite. Now we go hypo. Root name, ite. Hypochlorite. So we've got perchlorate, chlorate, chlorite, hypochlorite. These are all on the back of your periodic table. But this is how we get those names. Let's try and name a few. Alright, we have KOH. K is potassium. Now look for OH. OH is not one element. It's a polyatomic ion. Look on the back of my periodic table, and it tells me that it is hydroxide. The next one I look at, okay, here's my metal. Got copper. Copper is a transition metal, so I need the Roman numerals there. NO3 is a polyatomic ion. Look on the back of my periodic table. It is nitrate. How do I know which copper? Well, NO3 is 1 minus total, and there are 2 of them. So copper needs to be an overall 2 plus, so it's copper 2. All right. Now both of these are polyatomic ions. This is really the only positive polyatomic ion. It's NH4. It's NH4 plus, and it's ammonium. Now ammonia, those are 2 different things. And I look up ClO4 on the back of my table, and I should know that it is perchlorate. So let's look at now the difference between a monatomic ion and a polyatomic ion. Okay, mono meaning 1, so it's a single ion. Something like Cl minus. Polyatomic ion is a group of elements, okay, with a single charge. I have something like SO4, 2 minus. Okay, state and name the formula for the compound formed from magnesium and chlorine. So Mg and Cl. Mg is in the second group, wants to lose 2, so it's a 2 plus. Chlorine's in group 17, wants to gain 1, so it's a minus. So I need MgCl2. We call that magnesium chloride. Always change the I, the ending. Now the name and formula for sodium ions and nitrite ions. Sodium, Na. Nitrite, look on the back of your periodic table, it's NO2 minus. Sodium's in the first group, but it wants to lose 1. Formula, NaNO2. The name, sodium nitrite. Gotta be very careful with your endings here. Ites, ates, and ides. Alright, so then you'll see at the bottom of the table, okay, a nice little flow chart with some questions to ask yourself as to how we name these. Okay, determine your cation and your anion, and figure out, does your cation have only 1 oxidation number? That means, is it a transition metal, or is it not? Okay, if it has only 1 oxidation number, that means it has only 1 charge. Okay, so things like sodium only have 1 charge. They're always a 1 plus. Things like iron are in the D block. They can have lots of different charges. And then you write the cation and the anion. Okay, anion is a polyatomic ion. You gotta be careful. Okay, like this one is. I need to look on the back of my periodic table. This is not a polyatomic ion. It's just oxygen. So that's why this one is oxide, and this is phosphate and not phosphide. Phosphide would just be P. Okay, but it's not. It's PO4.